Hello. So as promised, we'll go through binary search again. What binary search does, right, is that if you are given a sorted, okay, firstly, maybe we talk about this. What does sorted array mean? Okay, we know what an array is. An array is a list of numbers. In this scenario, it's a list of numbers. But when you talk about a sorted array, right, it means that it is a list of numbers where the numbers, right, they follow a particular pattern. And this pattern, it can be ascending, can also be descending. It doesn't really matter. In our case, right, we would assume it to be ascending. In our ascending sorted array, what we have is we have this. Let's say this list of numbers: 1, 3, 4, 5, 7, 9, and 14. And we are given this sorted array, and we want to find where, and we have a key. Let's say the key is equal to 10. We want to find where is the key in this array. So there is 0, 1, 2, 3, 4, 5, 6. In this scenario, key number 10 occurs in position number 6 of the array. So in our scenario, right, we are saying that we want to find, for this sorted array, for the key 10, we want to find number 6. We want to find the number 6. How we do is the following. The technique that we are looking at is called a binary search. In this binary search, we compare the key against the middle and feed. So remember in the lectures that we talked about, you want to search for a number, you choose the middle number first. You choose the middle number first, and after that, right, you decide whether you want to go to the left side or the right side. If it is smaller, you search to the left side. If it's larger, you search to the right side. And if it's equal, you return the index. So let's look at the algorithm. So there were some questions that were being raised. So like what is low, high, middle, and what's the key? We go through them slowly one by one. Firstly, your A, right, is your entire array. In your entire array passes through every single time. So every single time you call the function, your entire array is passed through. Similarly, your key as well. Key is also passed through every single time. What changes, right, at every iteration is your low and your high values. The low and the high values, they determine the parameters where you want to search. So for example, at the very, very beginning, you want to search from 0 all the way to 9, because you want to search for the entire array. So it's 0 all the way to 9. But as you iterate through your binary search, your search space gets smaller and smaller and smaller. Let's now look at how does the search space get smaller and smaller and smaller. I'll go into this first line later on, but let's look at this line first. So we call that we want to look at what is the middle item. So in this example, right, let's say my items are 0 and 9. My middle item is at 4. To get this middle item, I take 0 plus 9, which is 9, divided by 2, which is 4.5. I cast it to an integer, I get number 4. And that is my middle item of that current array that I'm looking at. What happens then is I compare this middle item with my key. And I'll realize that this middle item if it is bigger than my key, I will search this part. So if my middle item is bigger than my key, I'll search this part. If it is smaller than my key, I'll search this part. Okay, let's look at the first scenario where it is smaller. I search this part, the left part. So now my low remains the same. It is still 0, which is low. But my high will be shifted now to this point. So my high will now be equals to middle minus 1. It will be shifted to this point. Similarly, for if my middle item is less than my key, which means that I'm searching the right half, my high remains the same, and my low becomes a middle item plus 1. Okay. So now I'm searching for this part. And I iteratively cut the array into 2, and I search through the halves bit by bit until I find the element. I know I found the element when it is not greater than the key and then it's not less than the key. And that's where I found the element. This is the scenario when the element is in the array. If the element is not in the array, what will happen is this line will occur where my low index will now be greater than my high index. And that is the scenario where I will return -1, which means that my key is not in my array. Okay. Let's try to look for an example where I can get this low greater than high. Let's say I'm looking for the key number 5. So I'm going to redo the whole thing. I'm looking for the key number 5. So key number 5 is not in this array. So firstly, my low will be at 0, my high will be at 9, my middle will be at 4. This will be less than my middle element, so I will come to this point. My high will be shifted here. 0 plus 3 will be 3, divided by 2, 1.5. This will now be my middle element. So now this is my middle element. This is still larger than my middle element, and so I will return low to be this. High will also point to this element. Is this clear? Because I'm returning middle -1. So both my high and my low will point to the same thing. Thereafter, I would find that my middle element is also at index number 0. Middle element, which is 6, is not bigger than the key. It's not bigger than the key. But middle element is bigger than the key. Is bigger than the key. So middle element 6 is bigger than the key. So what you will return is you return low, middle -1. Low is 0. Middle -1 is -1. And this is the point whereby my low becomes greater than my high. And you return -1. So this is a scenario whereby I have a element that's not in the list. Let's do one last example whereby my element is in the list. Maybe I should have done this first because it's easier to visualize. Let's look at 53. Okay, this one. So firstly, 0, 9. 4 is my middle. 33 is smaller than 53. So I'll be searching for this part of the array. My low gets shifted to this. So now I want to look for my middle element. 5 plus 9 is 14. 14 divided by 2 is 7. So now I have this number. Now let's look at the algorithm. My middle element is 53. Is 53 greater than my key? No, it's not. Is 53 less than my key? No, it's not again. And so means that I found my key and I'll return the index to my key, which is 7. Okay, I hope this is clear. And just email me if you have any other questions on this. Thank you so much. See you again.